We're going to talk about fitness to yearling age in the F1 progeny here. There are a couple of different aspects to this, so I'm going to chop and change a little bit through this talk. So why are we interested in fitness in livestock breeding? So most of the time when people talk about fitness in relation to livestock, it's to do with reproductive performance and survival. In beef and dairy cattle, they talk about traits like longevity and stayability. But fitness is not just about survival. It's also about how suitable those animals are for the production environment. And in this particular environment, they need to be able to survive droughts and floods and everything in between. So it's not just about survival, it's about how well they thrive in that environment and how much they cost you to produce whatever it is that they are producing. So in terms of time, labour, dollars, all of those things. So currently there's no single measure of fitness, if you like, and that's what we're trying to work on here. Just to set the scene, this is where the mortalities happen in the F1 progeny, and you can see there that by far and away most of the mortality happens in that neonatal phase between 0 and 7 days of age. Now, with regard to this fitness trait that we're trying to develop, I guess the end game is to develop a single numeric value that describes all of the fitness compromises that an animal experiences. So the way I've gone about doing that is using this matrix. So along the top it has increasing severity of the challenge that's experienced, and down the side there's a list of different sorts of challenges that they experience. So the first 4 are things that are recorded fairly early in their life, but then after that it focuses on some of the other major compromises to fitness, particularly in this environment, which is to do with flies and worms. And so basically what we're trying to do is assign a numeric value that actually goes up exponentially as the challenge gets more severe, and the idea is to end up with a single numeric value that we can analyse quantitatively. So when we do that, we end up with results that look something like this. And this is not that different to the birth weight graph I showed earlier. What we've got here is all of the size along the bottom axis and this thing that I've just called a fitness score. So the number itself is quite irrelevant. The important thing is the amount of variation between the size. And you can see there that there's a threefold difference between the best progeny groups and the worst in terms of overall fitness compromises, which are a conglomeration of all of those different categories of challenge, if you like. Just to give you some really preliminary idea of results that have come from this so far, that I'm not going to go into any details, but there are some general trends that we're starting to see, and they are that animals, all progeny groups that have poor neonatal fitness also tend to have poor or low fitness at the later age, at this stage only up until yearling age, but we will continue to measure those animals for their entire life. Animals that have relatively poor fitness also tend to have lower survival to yearling age. And we're also starting to see some favourable relationships between fitness and some of the important production traits. And the traits that have the strongest genetic correlations with fitness that we're finding at the moment include things like carcass fat and eye muscle, and variation in fibre diameter and staple length are the ones that are standing out at the moment. What I've got here is the relationship between breech wrinkle and breech strike among the 28 sires that were used at Armidale. So what we've got is sire within flock breeding values for breech strike and breech wrinkle. And if there's anybody out there that's still perhaps sceptical of the relationship between wrinkle and breech strike, hopefully this might convince you otherwise, because certainly in this flock, in this environment where DAGs is not really a problem, wrinkles is certainly related to fly strike. Now, just before I finish, I just want to talk a little bit about the wethers, and Brad will talk more about those in a few minutes. But the wethers run in a completely separate project to the MLPUs. And what we did with those was, after weaning, they were split two ways, effectively balanced for sire groups and birth types and weaning weight and all sorts of things. So effectively the wethers were split into two equal groups. One lot went down the path of being retained as wool growers until they're 3-year-old, and we've still got those. And the others have been sent down a feedlot finishing path for several reasons. So what happened with those was we backgrounded them here at Chiswick, then they went to feedlot up at Goondiwindi, and then they were slaughtered by Fletchers down at Dubbo. One of the reasons for doing that was that we want to challenge these animals for diseases, and so when they went to slaughter, we had an AQUIS inspector on the slaughter floor assess carcass and offal data for incidence of disease. We got one carcass that was actually condemned due to peritonitis, but otherwise the more interesting thing was that in total there was 17% of animals that went to slaughter were identified with some kind of disease, either currently or at some time in the past. So what I mean by that is that those animals were not necessarily sick, and probably were not sick at the time they went to slaughter, but they either have had subclinical disease at some point in the past, or even actual clinical disease that they've recovered from. And so there's evidence still in the offal and the carcasses that they've had some kind of issue in the past. And that's what we're interested in. That's why we sent them to feedlot, to challenge them for diseases, to look for variation. This table here shows you the sorts of things that they look for when they're doing carcass and offal inspection at the abattoir. The things on the left-hand side are those that were actually observed in at least one MLP sheep, and the numbers in brackets show you the numbers of animals that were recorded with those things. And the things on the right-hand side, there were no animals in the MLP flock that were identified with these things. So the important ones are the ones with the red ring around them, and they're the most common things that they saw, and also what you would expect to see from animals that have been through a feedlot finishing situation. And that's exactly what we were trying to achieve, was to generate some disease challenge in these animals. And so what we see from that is, again, another one of these graphs that has the 28 sires, and this time on the side we've got the disease incidence at slaughter, and you can see that there is enormous variation between the sires in the sires progeny groups in terms of the amount of disease that was observed at slaughter. So you can see that there was one sire that had no animals with any, no progeny with any sign of any disease, and yet there are several other sires that had more than 40% of the progeny had evidence of having some kind of disease, either active or subclinical, at some point in the past. So really big variation there. So in summary, I guess what we're trying to say from all of this is that cost of production is a really big part of the overall profitability of your sheep enterprise. Fitness for the production environment is a big part of that, and we shouldn't forget about it. And Brad will talk more about that in a few minutes. So just to finish up, again, I'd like to thank a few people, and in particular the technical staff at Chiswick, because they're the ones that have to do the fitness recording. They record on an individual basis every animal that has anything wrong with it at any point in time. So thanks, guys.